Good morning, students out in virtual school. I hope everyone's having a fantastic Tuesday. My name's Stephen, and on the other screen, there's another Stephen. How's it going, Stephen Lang?
It's going great.
That's awesome. Before we do our sort of morning routines, just any preview as to what students, what's in store for our virtual students today?
Yeah, so in the past, we've talked about, some of the big stuff out in space. We have talked about robots, and we have talked about the human side of space exploration. Today, we're going to focus a bit more on our neighborhood, the solar system, and talk about the planets in our solar system.
That's super exciting. All right, well, I'm going to just get our morning routine started, and we'll be back in a few minutes.
Great.
Awesome. Okay, students, we're going to start our day with our land acknowledgement. I encourage you to stand along with me as I read it out. We acknowledge we are hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples. Please remain standing for the playing of our national anthem. All right, that was awesome. Steve, I'm just going to pull up and add to the stream your presentation. Awesome. And as we enter Voyage to the Planets, I'm going to go full screen whenever you tell me you're ready.
Okay, let me just pull it up on my end. Hopefully everyone can see the logo there.
Yeah, we're all good. I'm going to go full screen, and you have a great session, and we'll see you in about an hour.
Okay, great. Thank you.
All right, bye.
Bye. Okay, everyone. So today we're going to focus in essentially on a voyage to the planets in our solar system. And I always like to start with this image. And of course, this is, if you think about where we live, this would be like the city in which we live. And of course, all the really big, cool stuff is out there in space. And where we actually live, this, of course, is our Milky Way galaxy, a spiral galaxy. And where we actually live is so small, you can't really see it on this scale. We live in a spiral galaxy, so the arms are spinning out like a pinwheel. And we live on one of those arms. It happens to be the Orion arm, about 26,000 light years away. And what I'm pointing to right there is actually not Earth, but something even bigger than that. And that is sort of our local neighborhood, and that would be our solar system. Now, we divide our solar system up into kind of different groupings of planets. We, of course, have the outer gas giants. So we have Jupiter, Saturn, Uranus, and Neptune. We will talk about Pluto a little bit later on, although it is not a gas giant. And then, of course, we have those inner planets, Mercury, Venus, Earth, and Mars. So the outer gas giants are huge, big balls of gas. And the inner planets, one of which is ours, are rocky. We call them terrestrial planets. And that, of course, is where we live. We live on Earth, which is a small terrestrial planet. And of course, we know that we have 8 planets in our solar system. Here's a great photograph to show them relative to one another as far as size. So you can see certainly those first 4 terrestrial planets are small compared to the big gas giants that are further out. They don't normally line up like this, of course, and they're spread out quite a distance. These are all grouped together. So really what they're doing is they are orbiting or circling around our star, the sun. And again, I've always liked to include Pluto because there's a lot of misconceptions about that. And we will talk about that a little bit later on. So let's talk about the planets. And a lot of people, when they are trying to remember the order of the planets, they sometimes remember their names, but they get where they are relative to one another mixed up, usually in the middle, often when I talk to classes. So a great way of remembering the order of the planets is by this saying. Now, there are lots of other ways. This is the one I use. So I remember my very educated mother just served us nachos. And if you can remember that, the first letter of each of those words is the first letter of the planets in the correct order, starting from the sun. So we have Mercury, Venus, Earth, Mars, Jupiter, Uranus, and Neptune. So we always like to start at the center, and there is our gigantic sun. And of course, that means that the first planet is the planet Mercury. There you can see it there. We've had some spacecraft circling around it and sending back images. That spot that you see there is just because that's an area where the spacecraft hasn't photographed yet. It takes many, many times around. They do it in small little bits, and then they piece the photograph together. So that's just an area that hasn't been photographed yet. Now, all of the planets in our solar system they're moving in 2 ways all of the time. We are aware of this happening on Earth because, of course, they revolve on that imaginary line called an axis once a day for us on Earth. And, of course, we also, as we've mentioned, all the planets are orbiting around the sun. So all of the planets do this, but they don't all do it exactly the same. So we're going to make reference to this on each planet. So Mercury, a day on Mercury, is actually a very long time because it is spinning very slowly. So 1 day on Mercury would be equal to roughly 2 months here on Earth. And yet 1 year is only roughly 3 months long on Earth. Okay, now if we lived on that planet, we would still call it a day in a year. So that's why we make reference to Earth days, Earth years, or Earth hours, so that we understand, we have some context about what we're talking about. So you can imagine if you went to school on Mercury, that your school day would last for 2 months. Of course, the good news is you'd only go to school 1 day a year because a year is 3 months long. Now, you wonder, does Mercury have any moons? Well, it doesn't. And then here's a question a lot of people get wrong. Does Mercury have an atmosphere? Well, it actually does, but it's very thin. We actually call it an exosphere, and it's always being ripped apart, blown away because it's so close to the sun. The sun gives off what we call solar wind, and that's what changing the atmosphere, the exosphere on Mercury, which is made up of oxygen and hydrogen and sodium. And being a small terrestrial planet, it is the smallest planet. You can see it's made of rock, and over the billions of years that it has been there, it has been impacted by other things, usually pieces of rock that are flying around in space. And so when we look close up on Mercury, we can see these craters or basins, and you can see it's got quite a few of them there. So it's a very rough surface. Some more images showing some of the surface, the rocky surface of Mercury. Again, more images I believe the yellow is hydrogen, so that's part of the atmosphere. Very, very, very thin atmosphere on Mercury. Now, big question is, do you think Mercury is hot or cold? Now, if you just thought about it as being so close to the sun, the answer would be that it's very hot. But the key to this answer is the fact that I said it spins very slowly on its axes. And so the answer to the question is both, because the side that faces the sun can get as hot as 430 degrees Celsius, but because the atmosphere is so thin, it doesn't take that heat and use it like we have on Earth, where it evens out the temperature. And so the side facing away, actually, and is facing away for a long time because it's moving so slowly, gets very, very cold. So the answer is both. It's hot and cold. And there's another great shot. We can use these images through different wavelengths of light to see different aspects of the planet's surface. And even under this wavelength of light, we can see a lot of those impact craters all over the terrestrial surface. So the next planet, of course, is Venus. The Venus is very strange. So yes, it spins on an axis. It spins backwards from most of the other planets. And another very strange thing is that its day is longer than its year. So one day on Venus would be equal to 243 Earth days, but 1 year is 225 Earth days. So Venus is a rather strange planet. Now, does Venus have any moons? No, it doesn't. Does it have an atmosphere? Well, you've already seen that. The answer is yes, and it's very deadly to us humans. So there's that atmosphere. It's surrounded in clouds. So in a way, yeah, you are seeing the planet Venus, but really you're not seeing the solid terrestrial planet. You are actually seeing the clouds of Venus. So we take those away using different technologies. We can actually peer through them, and we can see the surface of Venus right there. Now, at some point in time, Venus used to be referred to as our sister planet. And that is because if you look at the distance these planets are away from the sun, they are pretty close to each other. In astronomical units, we're looking at 0.75 and 1, not a big difference. And you can see here the size, they're about the same size. And after that, the similarities go away, because Venus is the hottest planet in our solar system. And it's because of those clouds. So those clouds, much like a greenhouse, will trap the heat from the sun, making the surface temperature around 500 degrees Celsius. And if you wonder how hot that is, if you talk to anyone who does a lot of cooking with an oven, you would realize we usually cook even something big like a turkey or a big roast at 450. So it's even hotter than that. Okay. Now these clouds are made of sulfuric acid, or similar to sulfuric acid, which means that they would burn or eat away at our spacecraft and our spacesuit. And then, of course, right now you've got air pushing down on you, but it's normal, so you don't feel anything. If you go high up in the atmosphere in an airplane or climbing a mountain, you notice the air pressure gets less. Sometimes in an airplane, your ears pop. You can also feel extra pressure if you go underwater, and that's the pressure of the water pushing down on you. Well, on Venus, that pressure from the clouds would be 90 times what you're feeling now. Imagine that, 90 times. So the surface of Venus is extremely hot. It is being corroded by the clouds, and it's got a lot of pressure. And that is why when we tried to land on it, it was actually the Russians made several attempts with multiple spacecraft. They all were failures. And finally, after all those failures, a spacecraft finally got through, landed properly, and then turned on and started to send back images and data from the surface of Venus. Here you can see those clouds. You can look, when I see it, it certainly looks like the surface has been baked in an oven. And of course, the pressure is 90 times, which is probably why, even though this worked, they got images and data for about 2 hours and then everything shut down. So probably because of the temperatures, the acid, and the pressure, one of those things finally got to the spacecraft and it shut down. But that's what the surface of Venus looks like. Now, of course, this is the planet we know the most about because this is where we live. Third planet from the sun, Earth. And of course, we know I'm rounding it up here, but one day is roughly 24 hours and 1 year, 365 days. But I do want to point out that this is the only place we've ever found life. Okay? So we have not, although we've sent lots of robots out into space to explore, we have not found any evidence of life anywhere else. And of course, we have one satellite. We call it the moon. I think we should come up with a better name than that. You'll see some of the names of other moons are much more interesting. Ours is just the moon, 400,000 kilometers away. And by the way, that is as far as humans have traveled. So we have not actually gone further than that. We've sent robots, but not people. And the image on your right is a great shot by some of those astronauts who went to the moon in the Apollo missions, looking back from the moon to the Earth. So, of course, the next planet is the red planet, and that is the planet Mars. In fact, on Halloween night, I was out looking out into the sky with some neighbors, and somebody asked, what is that red dot in the sky? And it turns out it is Mars. So if you go out, if the nights are clear, I noticed it again last night, look for the moon and then look over to its right. Quite a distance. It's not right next to the moon right now, but it'll be above and to the right. You will notice a fairly bright object, and it does appear red, even from Toronto, and that is the planet Mars. And of course, the red color comes from the iron in the soil. Now, Mars is somewhat similar to us. Its day is just a little over 24 hours long, but being in a larger orbit, its year is 687 Earth days, so quite a bit longer than ours. Now, does Mars have any moons? Well, it does. It has 2 moons. And does it have an atmosphere? It does, but like all the other planets, it is deadly to humans. So its 2 little moons are Phobos and Deimos. They're not very big, and they orbit the planet fairly close to Mars. So those are the 2 little moons of Mars. And its atmosphere, there's an image of it there, is very thin. So we talked about going to Mars and maybe colonizing Mars, things like that. Well, one of the things you have to realize is that the atmosphere is CO2, so it's very deadly to us. But even if it was air, it's only 1% of the air or the air that we have here. So it's very, very thin. So even if it was air, there wouldn't be enough of it for us to breathe. So we do need that air pressure around us at all times, as well as needing the air to breathe. So not a place where we can go without building shelters and bringing the air with us to breathe. Now, Mars has got some of the best features in the solar system. So here is Olympus Mons. This is the largest mountain in the solar system. It is actually a dead volcano. And there you can see, compared to Mount Everest, which is the tallest mountain on Earth, it's about 3 times taller than Mount Everest. Okay. Now, because it's so tall, it's also got a huge base. You saw that in that first image. And if you were to place that here on Earth, its base is about the size of, here you can see it almost fills France completely. Or if you look on another map, Arizona. It is a very, very large mountain, dead volcano. Here is we call it the Grand Canyon of Mars. It's a kind of a scar. You've seen it in the very first image, and that is Valles Marineris. And there's a shot of it right there. It's a large scar that goes right across the surface of Mars. And if you compared it to the United States or Canada, it's about 4,000 kilometers long. So it's quite long in comparison. You see it in this picture. You don't realize how big it is until you get this comparison. You realize it would actually go from one side of Canada all the way across to the other. And if you've ever been to the Grand Canyon in Arizona, which is very impressive, this canyon would be hundreds of times longer and several kilometers deep, much, much deeper than the Grand Canyon. Now, Mars being somewhat close to us and a rocky terrestrial planet, we've decided we know that we can't really go and explore Venus. Its heat and pressure and everything is just too difficult for us to try and explore. And so Mars, being a close planet, is one that we can go to. It's terrestrial. We can land on it. And so that's what we have been doing since the 1960s. And when we first went there, we were wondering about trying to land and what that would be like. And we did send some spacecraft to land and actually even check out to see if there was life elsewhere. That's a big question we would like to answer. Is there life somewhere else in our solar system, in our universe? And so once we realized that we could easily, relatively, get to Mars and land, we've been getting better at it, we decided that we wanted to then send rovers to try and drive around on the planet, not only just looking for life, but also trying to find out what Mars is made of and get a better understanding of our solar neighborhood. So in the 90s, we sent that small little robot that you see there, and that was just a test one to see how it worked. And then we decided once we knew that we could do that, we sent a much larger rover. The first one was called Sojourner. The next one, there was actually two of them, Spirit and Opportunity. And that's the one kind of in the middle. That's about the size of a kitchen table, like I said, with a 5-foot mast with cameras. And so as it explored around the planet Mars, it gathered information and sent it back to Earth. The two spacecraft were there. The last one survived for 15 years before it stopped working. And then in 2012, we sent the much larger space rover that you see here. This one's called Curiosity, and it's currently on the planet right now, driving around. And there's an image from the Curiosity spacecraft right there. And of course, like I said, the reason that we're doing all this is we are looking for life on Mars. Now, we haven't found it yet, and if we do, it'll very likely be a bacteria of some sort. It won't certainly look like this. But we've gotten smart. When we first started sending rovers there and robots, they would just land. And we realized, well, all the life that we know of requires water. So before we send, and these things cost hundreds of millions of dollars, before we send another robot to the planet, we should probably find out, A, if it has water and where that water is. And so we spent the time to send another robot that orbits Mars and looks at the whole planet and maps it for water. And here you can see all of the blue stuff is water on the planet Mars. So now when we send robots, and we sent one this year takes about 7 months to get there. It will land where they have found water so it can start looking for evidence of life. And we have discovered that there is a lot of water on Mars. Mars typically is about minus 60 degrees, so it's extremely cold. So a lot of that water is frozen, and a lot of it is under the surface of Mars. Now, much like Earth, we have seasons on Mars, and so when it's warmer in the summertime on Mars, the water can actually flow. The water is got a lot of salt in it, and so that helps it. And you can see these two images here. One, it's the same area on Mars. One is when it's frozen, and the second one is actually showing the water flowing under the surface. And what we discovered with some of those robots is that Mars, millions of years ago, actually was much more like Earth than we realized. And actually there was a lot of water, almost as much as there was here on Earth. So of course, one of the questions now that we've found that is, where'd all the water go? There's still lots of water there, and it's frozen, like I said, but there's still a lot of it that's missing. And that's a great question. Mars had more of an atmosphere. So that's another question that we'd like to find out, because if Mars used to be a lot more like Earth and is now very cold and barren with very little atmosphere, could that happen to Earth? So those are some new questions that we are now trying to find out from our exploration. Now, often when we show this picture, if I don't put up a label, this is the first of the gas giants. This is Jupiter. If we don't put up that label, because people see the ring, they often think that this is Saturn. But Jupiter has rings. Okay, some of the gas giants have rings. And its day is about 10 Earth hours long. Okay, so shorter than ours. And its year, you notice how the years are now getting longer and longer. So 1 year on Jupiter is equal to about 12 Earth years. Now, does Jupiter have any moons? Yes, it does. In fact, it used to be the leader in the number of moons at 79. We'll talk more about that in a few minutes. And of course, the question is, does it have an atmosphere? It is a gas giant. So pretty much the entire planet is an atmosphere. Primarily hydrogen, which is not something that you want to bring in. And as you can see here, these different colored bands on Jupiter are the winds on Jupiter blowing, some of them at 500 kilometers per hour. And you see the different colors and the swirling aspect to that. So some of those winds are blowing in one direction. Often the band above it is flowing in the opposite direction, again at hundreds of kilometers per hour. And Jupiter is huge. It is the largest planet in our solar system. And one of the things we noticed about it is that it had this storm. Like I said, the winds are blowing around all over the place, but there is an area where the winds are blowing kind of in a circle. And we've been watching that for about 200 years. And when we first started to look at it, to give you an idea of just how big Jupiter is, it was about the size of 3 Earths. And just last year, astronomers watching this spot, great red spot on Jupiter, started to notice that it was shrinking. And there was a lot of speculation, would it finally shrink and disappear after hundreds of years? It hasn't, but it has shrunk down now to about the size of 1 Earth. Now, that doesn't mean the planet itself has shrunk down, just that that storm has. And who knows, maybe it'll stay like that for hundreds of more years, or whether it might get smaller, it might get bigger again. We'll have to wait and see. Now, Jupiter used to have the record for the most moons at 79. I said earlier that the name of our moon is kind of boring by comparison, the moon. And here we have just a few of them: Io, Europa, Ganymede, Callisto. So we've come up with some more interesting names for the moons of Jupiter. And one of the things, we've been sending spacecraft out into space to explore, and one of them, when they went past some of these moons, not only are they taking measurements, but they're taking images as well, and they found something very interesting on some of these moons, one of them being Europa. Europa has got a lot of water on it, as much or more than we have in North America on this one tiny moon. You think about that. Think about all the water we have in North America, the Great Lakes, rivers and streams, all the lakes up north. That's a lot of water, and all of that on this tiny little moon. Now, what we also realized is that the outer surface, being exposed to space, which is extremely cold, is frozen, but they did notice that there was something being blasted out into space, and when they recorded that and measured what it was with different equipment, they found out that it was water vapor. And so this led them to believe that the core of some of these moons is actually heated. And what it's doing is it's heating up that water and causing it to blast out into space. So, of course, that's great if we are trying to answer that question: is there life elsewhere? Remember, we said on Mars that we were looking for water because we know that pretty much all life on Earth requires it. So now we have found water on some of the moons of Jupiter, as well as some of the moons of Saturn. And water is actually more prevalent than we realize. We actually, when we first went to the moon, we didn't think there was any water there. And because our technology has gotten better, there's not quantities of water on the moon like you would think of on Earth. It's all frozen and in the rocks, but they've actually found quite a bit of water on our own moon. So water is something that we feel is fairly common, at least in our solar system. So the next big gas giant, of course, is Saturn, which of course is known for its ring system. Like we said, not the only planet that has rings, but certainly the one known for its ring system. And again, much like Jupiter, it is a big ball of gas, primarily hydrogen, helium, and methane are the main gases. So one day on Saturn is almost 11 hours on Earth, and 1 year, again, we're going longer time, and that is 29 Earth years. So does Saturn have any moons? Yep, it's now the record holder because we're always studying images. Some of them are very small, and we have discovered a few small ones. And so it's just recently taken over the lead for the most number of moons at 82. And much like the other gas giants, does it have an atmosphere? Yes, it is entirely an atmosphere. It is a big ball of gas, and like all the others, very deadly to humans. So there are some of the 82 moons. Enceladus is another one that they found water on, and Titan is actually one of the first moons that we tried to land on. It was in the 90s, and the spacecraft actually went through the rings. We'll talk about that in a sec. And landed, dropped a spacecraft on the surface of Titan. And this was in the 90s, the late 90s. What was amazing is when it sent back the first images, it actually looked like they had dropped the spacecraft on a beach somewhere. They saw what looked like water on the edge of a shore. When they measured it and analyzed it, they realized it wasn't liquid water, but liquid methane. So that made it kind of a very interesting discovery on the planet Titan. So back to the rings, of course, Saturn is known for its ring system. And here you can see it. When Galileo and other astronomers first looked at it, they, with their primitive telescopes, thought that they were solid. And certainly a lot of images that are from Earth, they're not that, not that close up, make them look like they are solid. But you can see here that the rings not only have gaps in them, there's some more images there, they certainly do look solid, but we have these huge gaps in between them. And when we look closer, we realize that these rings are actually made up of big chunks of rock, but also ice. So one of the reasons that we can see Saturn's rings much easier than, say, Jupiter or some of the other planets is two reasons. Jupiter's rings, compared to where we are, we're looking at them edge on. So there's not a lot to actually see. And they're mostly made of rock. And rock doesn't reflect light very well. Whereas Saturn's rings are kind of angled towards us. So we see the bigger profile for Saturn's rings. And because they have a lot of ice in them, ice, as we know, is reflective and therefore makes it that much easier to see. So trying to pass through these rings is quite a challenge. So the fact that the spacecraft actually passed through the rings is pretty impressive. You can see it's not as easy as you might think. And by the way, one of the cool things, again, we're talking about Saturn being a big ball of gas, so it's actually very, very light. And if you could find a swimming pool or a lake big enough, of course, it'd have to be huge, Saturn would actually float in water. Now, Uranus is a rather strange planet, besides the fact that everyone mispronounces it. Okay, another big ball of gas, not as big as Jupiter or Saturn, but certainly quite large. And the blue color comes from methane, hydrogen as well, but methane gives it its blue color. So one day on Uranus is 17 hours. We're now at 84 Earth years for 1 year. And like Venus, Uranus is spinning backwards, but it's also, as you can see here in the image, the small image with its rings are made of rock, it's spinning on its side, almost at 90 degrees. So kind of odd planet. So does it have any moons? It has 27 moons. And again, like all the other gas giants, it does have an atmosphere. And there's the image showing it spinning on its side. So the two odd planets that we have in our solar system are Venus and Uranus. They both spin backwards from all the other planets. Okay, we are going, you look in the sky, you see the sun goes from east to west. Here, it would go the opposite way. Uranus is completely on its side and spinning backwards. And then officially the last planet in our solar system is Neptune, a big ball, again, of gas, and the blue color comes from methane. And when you look, these images were taken by the Voyager spacecraft that flew past. You can see two spots on here, a big spot right in the center, the great dark spot. Again, much like the storm on Jupiter, it is a storm that is swirling around. And then there's another little one kind of in the lower left near the bottom. That one they called Scooter because as they were filming this from the Voyager spacecraft, it seemed to be scooting very quickly around the planet. This was in the 80s. When they look at this planet now and study it, they find that neither of those storms seem to be there. Maybe they've blown themselves out. Maybe they are just stuck somewhere else on the planet and we can't see them. Again, like all the other planets, it is revolving on an axis. This one happens to do it once every 16 Earth hours. That would be 1 day on Neptune, and 1 year is 165 Earth years. Does Neptune have any moons? Yep, it has 14. It also has rings, and As a gas giant, it also has an atmosphere. So what about Pluto? Earlier, you saw that I included Pluto, and certainly when I was going to school, Pluto was considered a planet. So we used to have 9 planets. And just like all the other planets, it is rotating and orbiting. So one day is about equal to 6 Earth days. But here's the interesting thing. Pluto takes 248 Earth years to complete one orbit. It is 7 billion kilometers away. So its orbit is very, very large. And Pluto was discovered back in 1930. So realize this, 90 years ago, we discovered Pluto, which means that since we discovered it, it hasn't even completed half of an orbit. And we were looking at the orbits of some of the other planets, and with mathematics and physics, we said, well, we think there must be something else out there in order to understand these orbits. And so astronomer at the time named Clyde Tombaugh decided that he was going to try and find this. They didn't have the technology we have today. They were using a camera, using glass plates, and observing what they found every night. It took them a year, and they finally discovered Pluto. And at the time, they just assumed what they should be looking for as a planet, and so Pluto became a planet. Now, from those earliest photographs, we couldn't really tell very much. You'll see one a bit later on, but it was pretty blurry and not a lot of information. Now, we did know that Pluto was relatively small. We thought it was at least smaller than our moon. And as you've seen in some of the diagrams, because we are on Earth, if we were to look out at all the other planets, us being the kind of the standard where we're looking from, we say we're 0, and then how much are they raised in orbit above us? And you can see here most of the other planets are very close to us. Okay, Mercury is way off at 7 degrees, which is the most, but then Pluto is at 17 degrees, and you've seen in some of the diagrams showing how Pluto is at quite a bit of an angle. There you can see it. Okay, so right away we started to realize as we learned more and more about it that it was a little bit on the odd side. And then we discovered that Pluto was not alone. It is way out in space, like I said, 7 billion kilometers away, in an area that we call the Kuiper Belt. This is an area of large chunks of rock and some ice. And back when we had 9 planets, some of the astronomers were looking for the elusive, what they believed was the 10th planet, or Planet X. So they were all trying to find this. And of course, had they found something that would make them rather famous in the astronomy world, well, they started to find objects that they thought should be planets. Now, I want you to understand, these objects are very far away and very difficult to find. So it takes a long time. So in the red images at the top, the arrow is pointing to one of those images. I believe that one is Sedna. And then we can see another one, UB313. And look how far away that is. If Pluto, if you're looking at the lower right-hand photograph, Pluto is 7 billion kilometers away. Look how much further UB313 is. So these objects are very, very far away. So the question came up, should these be classified as planets? Well, that was a question. And the astronomers, believe it or not, did not themselves have an idea what a planet was. They could talk about it, but there was no official definition. So in 2006, they had a big meeting and they argued for a long time about what a planet was. And they finally came up with a description. This is it. So the first part makes a lot of sense. It is in orbit around the sun. Number 2 is that because of its mass and gravity, it has basically made itself round. Number 4 is, well, a satellite is also called a moon. So if you have an object orbiting a planet, that's a satellite or a moon. You don't have planets orbiting planets. And it was number 3 that they argued about. Number 3 is this. It says, look, if you are the biggest thing, everything has gravity. The bigger you are, the more gravity you have. So if you are the biggest thing in space, you will pull in, because of gravity, all the smaller stuff, which then makes you bigger, which then creates more gravity. And so in the billions of years that these objects have been orbiting around the sun, if they are the biggest thing, they will have gone around cleaning around their neighborhood by pulling in all the smaller stuff until there is nothing left. Well, this was the definition they came up with. So right away, as soon as they agreed upon this, they realized that Pluto does not qualify because of number 3. Remember, Pluto is out in that Kuiper belt, an area surrounding it that has chunks of rock, some of which are bigger than it. So now what do? So they decided, being fairly smart people and not wanting to spend another week arguing over a whole new definition, they decided to just add 2 words to this one to define a new object that we call a dwarf planet. So that is what Pluto is. And the only difference is they say in number 3 that a dwarf planet has not cleared the neighborhood around its orbit. So I want you to be clear on this. A lot of people think that Pluto is not a planet because it's too small, which isn't exactly correct. Certainly size is one of the factors, because if it was the biggest thing and had cleared its neighborhood, it would be a planet. But nowhere in this definition or the one before it does it say you have to be this big to be a planet, or if you're too small. It's saying it has not cleared the neighborhood around its orbit. So right now we have officially 5 dwarf planets. Here they are. We've added the moon. It's not a dwarf planet, but it's just there to help give you an idea of size. So of course, Pluto is one, along with Haumea, Makemake, Eris, and Ceres. And most of these objects are out in the Kuiper belt, way out there with Pluto. But the closest one is Ceres, which is just past Mars in the asteroid belt. Again, a region of big chunks of rock. And that's what Ceres looks like. Certainly it qualifies under that round category. This was taken by a spacecraft, and what they do is they fly close to the object, and then they take photographs and send them back to Earth, which of course takes time. But the spacecraft does not stop. It continues flying. So unfortunately, in this case, when they finally got the images of Ceres back on Earth, the spacecraft was long past Ceres, and that's when they saw these bright objects. They almost look like lights. They believe that these are some sort of crystals that are reflecting the light from the sun on the surface of Ceres. So talking a bit back about Pluto here, here's some of the images of Pluto over the years, and you can see that very first image taken in 1930 by Clyde Tombaugh, certainly compared to what we have today, is not very big. How they decided that this would be a planet, I have no idea. And even with the technology of the 80s, the Hubble Space Telescope, which is still in orbit around us, you couldn't get a very clear image. And then what they decided to do was they decided to send a spacecraft to Pluto to study it and gather information and images. It took 9.5 years for the New Horizons spacecraft to travel that distance, and we finally got some good images of Pluto. So in 1930, we had something like this, and then we finally got a really good image of Pluto, and it looks something like this. And Pluto is a frozen ball. It does have a methane atmosphere. And I forgot to throw a slide in. It does have some moons to answer that question. It doesn't have rings, but it does have 5 moons. The biggest one is called Charon, which is almost the size of Pluto as well. So it's kind of a weird arrangement with the planet or dwarf planet and its moon being so similar in size. And we finally were able to determine just how big Pluto was. And Pluto, as we thought, is small. In fact, it's about the size of Australia. So that's it. That's a bit of a short tour of our solar system to give you an idea of each of the planets. And of course, there we are, the third planet from the sun. And just to give you a sense of how small we are in looking at ourselves from other planets, like I said, we have lots of robots on Mars. So here is a picture that one of those took of us. Like I said, try going out, because if you go out at night, you can see the reverse of this right now anyway. Look up in the sky and you will see the moon, and then look to the upper part and to the right, and you'll see a red dot, and that is Mars. And this is what we look like from the edge of our solar system. That spacecraft that was, or there's two of them actually, that were flying around in space, Voyager 1 and Voyager 2, taking photographs and gathering data on all the planets. That's the reason we know what we do about these. On Valentine's Day 1999, took this image from about 6 billion kilometers away. So that is Earth. That is us. And I want you to think about that for a second, because on that little dot is every person you've ever known, or every person you've ever read about in history. Everything from the dinosaurs to now, every plant, every bug, everything we've ever known, every book that's been written, every piece of music, everything has existed on that one tiny dot. And that's really only a small part. I mean, here we are. There's the Earth. There is our solar system. And as we pull back a bit further, these are some of the bigger stars that are all around us. And again, here's our Milky Way galaxy. You can't even see us on that scale. So I hope that helps you guys have a better understanding of our solar system and the planets that are in it. So thank you very much.
Wow. That was awesome, Steve Lang. As always, you have made me feel infinitely
Space has a
small.
way of doing that to us, that's for sure.
Yeah, I was wondering, and not to put you on the spot, so by all means say I'm not sure, but do you know of any? I don't know. I'm just thinking like great tools or apps or free things students might be able to use to just kind of explore the galaxy from their own device or anything like that that you
Well,
might
there's a lot of
that you
apps
might
out there,
suggest.
depending on what it is you want to study. There's a number of apps. Stellarium is one where you can explore on your laptop some of the stars that are out there. Another one, if you're trying to look, we talked about the 8 planets in our solar system. Well, the fact is there are 4,000-ish other planets. We call them exoplanets. So there's a called exoplanet, I believe it's called, and it'll tell you when they discover new planets outside of our solar system. And then the other one, Star Walk, and there's a number of other astronomy apps where if you are outside and you look up in the sky and you go, I wonder what that constellation is, or what is that bright object? You can pull it up on your phone and you just hold it up and it'll actually track and tell you what you're actually seeing. So there's a number of them.
Based on my sort of
Yeah,
geographic
so it figures out
location,
where
that
you
kind of
are,
idea.
and
Wow.
even without data, it seems to work. So you can be outside and turn it on, and then point up at the sky and try and identify what you're looking at. So there's a number of apps certainly out there that you can do that with.
Hmm. That is super cool. So maybe we can break down some of those apps in a
Yeah.
future virtual episode. That'd be fun. Awesome. Okay, well, I want to thank you now. I'm going to just switch over to our presentation, and this would be time to sort of bid farewell to Steve Lang, and thanks again for giving us a great tour and starting place to kind of understand the planets that are within our solar system. And I just want to
thank you
thank you
guys.
for
Hope you
giving
enjoyed
us
it.
your time today. All right. Okay, students at home, if you're still with me, I can see 26 of you are. Don't forget to give yourself a brain break today and get some stretching going, even if it's just at your computer. Make sure you get some movement going. There's a couple of great brain breaks for you there. More learning activities available for you from this presentation. And if you're familiar with the Virtual Schools website, that's there for you to use. Don't forget, you always have access to TDSB's virtual library, and instructions on how to access that from home are included in this presentation. Great things there, particularly if you are interested in space and taking that conversation further. Highly recommend Britannica Online. As well, if you're having any challenges, there's always the student virtual learning IT support available to you to troubleshoot problems you might be having with your device. And as well, I just want to thank you on behalf of myself and Steve Lang for joining us our session today, and we'll see you soon.